All right, guys, welcome. We're into lesson 3. It's probably Wednesday. I don't know. I'm sure what day it is unless we got off track here. We have functions and equations. Tough chapter. A lot of algebra in here, a lot of abstract thinking. So hope you're doing your homework. Today we have a new term. It's called a linear function, and that just means that it's going to lie on a line. I talked a little bit about how those are falling on the line a little bit earlier in the week, but let's get circled up right now for the homework. We have 1 through 8. Okay. All right. And I got those circled. And number 8 is here. And then we're going to jump to 14 through 28. And actually, we're going to change that to 13 because we need to do that problem, that's for sure. Okay. And you know what? Let's pause on that. We're not going to stop there. So we're going to stop at number 18 here. Okay. So that's quite a bit of work there. All right, let's put this back together. And let's talk about this term called a linear function. A function is a rule. Linear means line. So when we do these rules, all of our dots, when we start to graph, are going to start to fall on a line in the coordinate plane. And you can see we're dealing just basically with the first quadrant, excuse me. But if we went into the other 3 quadrants, it would still fall on that line if we dealt with some positive or some negative numbers, some integers, right? So let's get rolling here and get into it. Okay, so the best way to do this is just more of the same. All right, let's go. Write an equation to represent the function. Now, when we write an equation, we had equations last chapter in chapter 7. All right, remember, both sides have to be equal in an equation. So when we write an equation, we're always going to start with y, all right? The letter y. So y is going to equal, how am I getting from here to here, here to here, here to here? And I need to decipher that. Now, 0 and 0 really doesn't help me. So I could get from x to y by adding 3, but adding 3 doesn't get me here. So we're going to have to go ahead and divide. 4 divided by 1 is 4. 8 divided by 2 is 4. 12 divided by 3 is 4, and so on down the line. So to get from x to y, which is what we're looking for, we're taking the x number and multiplying it by 4. So our rule is called y equals 4x. 4 times any number up here will give us the letter y, and we could graph that with these if we needed to on a graph, like we're going to do to number 2. Number 2 is an interesting. They don't give us any numbers, so we're going to plug some numbers in, right? And the numbers that I'm going to use are really just 0, 1, 2, and 3. And I like to do 3 numbers. I'm going to do 4 here, but I'm going to plug these numbers in for x. So 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. And 3 plus 3 is 6. All right. These were our x numbers. Our y numbers are now these, right? So our ordered pairs are x is 0, y is 3. And we want to write it like so. The next ordered pair is x. Remember, we gave x is 1, and y is now 4. The third ordered pair, I said let's use 2. 2 plus 3 is 5. So x is 2, and y is 5. And then finally, the last one is 3 and 6. So I'm plugging these numbers in. Where did I get these? I just made those up. Any number would work here. But I use smaller numbers because my graph only goes up to 8. So let's go ahead and graph, okay? So we have 0 and 3, which is right there, okay? And when we're doing linear pairs, we're not going to draw or put the ordered pairs there. I ran out of lead here. Hopefully it will come through. And I've run completely out of lead. So let me switch pencils here. And we're in good shape. Okay, the next one is 1 and 4. The next ordered pair is over 2 and up 5. The last one is over 3 and up 6. Okay, and those are our ordered pairs. And if I were to draw a line, you would see that these all fit on this line, and this is called a linear function. Any number I put in for x will fall on there. All right, any number. Okay, all right, let's continue on. Number 3. The graph below shows the number of inches of rainfall x equivalent to the inches of snow. So 1 inch of rain to snow. Make a function table of input and output. Here's your input, here's your output values. Write an equation from the graph that can be used to find the total inches of snow y to the inches of rain x. Wow, there's a lot here. All right, so how are we getting to y? All right, well, it looks like the first ordered pair is x is 1, y is 10. The next ordered pair is x is 2, y is 20. This is an out, that's all. The third ordered pair is 3 and 30, and the fourth ordered pair is 4 and 40. You can clearly see that they intersect on those lines. Now, we need to come up with a function rule, and to come up with a function rule, we always start with the letter y. Y equals, how are we getting from x to y? Well, if we multiply 10 by any of these numbers, we're going to get that. So it's going to be 10x. 10 times x gives us these numbers, which is the letter y. Here's our function rule. Here's our function table. Okay. All right, let's continue on. And let's get into the homework here. All right. So, number 1, it reads, and it says, write an equation to represent the function. All right, let's start over here. All right, so we always start with the letter y when we write our function rule. How are we getting from x to y? Well, you clearly can see that it's multiplied by 6, so 6x. 6 times any number up here gives us y, the output. Remember, another name for input is independent variable. This is dependent. Number 2. Okay, let's look. 0 and 0 really doesn't help us. Plus 14, no. 15 divided by 1 is 15. 30 divided by 2 is 15. So it looks like we're multiplying these numbers by 15 to get y. So y equals 15x, right? 15 times any of these numbers gives me this number down here. Okay, here we go with our graphing. And we're going to do this one, and I'll come down and take a look at this one, number 6, and then the rest will be on your own. So let's go ahead and figure out some numbers for x. So we're just going to come up with numbers because our graph's not real big. So the numbers I'm going to plug in for x is going to be 1, 2, and 3. And what we want to do is just use these numbers. We only need 3 samples, and make sure that it will fit in nicely for us. Okay, so the first one is y equals x plus 4. Well, if x is 1, all right, 1 plus 4 is 5. All right, so we have to understand that the first ordered pair is going to be 1 and 5. Where did I get this 1? I came up with 3 sample numbers. How did I get the second number? 1 plus 4 was 5. The next one, if we plug in the number 2 here. So x is now 2. 2 plus 4 is 6. Y is 6. And then finally, if I take that and if I plug the number 3 in for x, 3 plus 4 is 7. So x is 3, y is 7. And let's go ahead and graph these on our graph. 1 and 5 is right there. 2 and 6 is right there, and you're going to see that they are linear, and 3 and 7 is right there. And if I were to take my protractor and draw a line, you would see that they would all fit on that line. Look, if it was zero, if that was zero, 0 plus 4 is 0, 0 and 4 starts right there. So we find out that it is linear, right? All right, last one I'm going to talk about is number 6 here. The graph shows the changes for a health club in a month. Okay, make a function table of input and output values. So we're going to have to come up with some input stuff here, it looks like. Write an equation that can be used to find the total charge, y, for the x classes. All right, well, I'm wrong. We have a graph here we have to take a look at. Oh, my. Let's take a peek here. All right, so we have a broken scale as well. So that tells us the first interval is bigger than the rest. See, the first interval here is 30, then they start counting by fives. So we have to be careful here. All right, so the first ordered pair is 0 and 30. So x is 0, y is 30. I got those numbers from right here. The second one goes over to 1 and up to 35. The third one goes over to 2 and up to 40. The third one goes over to 3 and up to 45. And there we have it. Okay. Now, we have to figure out the function rule, and this is probably the most difficult piece of this. This is actually going to help me because nothing times 0 is nothing, but I have to add 30. You see, I have to add 30 to get from 0 to 30. So I know part of the rule has to be plus 30. Has to be. Now, if I add 30 to this, I only get 31. So it looks like I'm going to need to multiply. But, you know, there's a way to figure out what number to multiply by. We can come across the y coordinate and see. There's a 5, there's a 5, and there's a 5. We're adding 5 here. This is a two-step rule. So if I take that number and I multiply it by the top and add 30, which I got from here, that should be a pretty good rule. And don't forget, we need the equation, so we have to start with the letter y. So here we go. 5 times 0 is 0, plus 30 is 30. 5 times 1 is 5, plus 30 is 35. And you're going to notice that that rule works. 5 times 3 is 15, plus 30 is 45. We have our function rule, we have our function table, and it is linear. Linear. All right, guys. Do the best you can. Keep plugging away at this stuff. We got one more lesson. We're looking at a quiz probably in a few days.